Hi friends, welcome to Curing Electronics. Today we are going to see a couple of problems on parallel and series combination of resistors. Now, all of you please share the video with your friends and please press the like button also. And so we'll start the lecture. Okay, this question will come back later. First we'll solve one question. So, we have resistors, there's a 1 ohm resistor, 1 ohm resistor is then there is one more resistor here, this also 1 ohm, and another resistor is connected like this. This is 2 ohms, 2 ohm resistor, and there is one more resistor coming to this point, that is 1 ohm resistor. This is our A point, this is our B point, and there is one more resistor here, that is, what is the value of it? It's a 2 ohm resistor. Now we have to find the value of resistance of this circuit, that is, if we connect a multimeter between A and B, the resistance mode, what value it shows. If you see, this is a combinational circuit of resistors, that is, resistors are connected in series as well as parallel. Now we will simplify this diagram and solve it. So if you see this 1 ohm and 1 ohm, these two resistors, if you see these two resistors, they are in series. They are in series. So what we can do, we can replace this with a single resistors. When two resistors are connected in series, what happens? Their value get added. That is RT equal to R1 plus R2 when they are in series. R1 plus R2. So 1 plus 1, 2 ohms will get. 2 ohms. This 2 ohms in parallel with 2 ohm resistor. In parallel with 2 ohm resistor. Correct. See, these two resistors and add up you will get 2, and this 2 ohm resistor both ends are connected to the other 2 ohm resistor, exactly parallel connection. Now we will just draw the remaining circuit. So that is, there is a 1 ohm resistor here, 1 ohm, and this is our A point, this is our B point, and what is there? There is one more 2 ohm resistor here, 2 ohm resistor here. Now again we see, if you look at this figure, this circuit diagram, these two resistors are in parallel. When two resistors of same value are connected in parallel, what is the equation for total or equivalent resistance? R divided by N. Here what is R value? 2. 2 divided by 2 will get 1 ohm, right? So we'll simplify this further. So these two parallel 2 ohm resistors get replaced with a 1 ohm resistor, that is 1 ohm. These two will be replaced with a 1 ohm resistor, right? This is 1 ohm. Again we have a 2 ohm resistor here, 2 ohm resistor. Now if you see this, if you see these two resistors, how they are connected? They are connected in series. How do you say it's connected in series? The series combination of resistors, current through the circuit is same. Okay. Otherwise, while looking at if it is connected back to back, you will understand how to identify after solving a few problems. You will be expert in identifying whether it is connected in series or parallel. So guys, what is happening? Okay, we'll solve it. Now we will draw the simplified diagram again. How it will get simplified? Now this 1 ohm and 1 ohm we will replace with a single resistor. So this will be equivalent to 2 ohm resistor. This is our A point. This is our B point. We have two ohm resistor parallel with it. 2 ohm resistor. Now when two ohms are these, we see these two resistors are connected in how? These two resistors are connected in parallel. Correct? Right, it's right. These two are connected in parallel because voltage across these two resistors are same. Now there is no voltage. By looking at itself, we can identify it is connected in parallel. Now this can be replaced with the equivalent resistance of 2 ohm. 2 ohm, is it 2 ohm? No, it's not 2 ohm. It is, these are the AB points. What will be the equivalent of these 2 ohm and 2 ohm in parallel? 1 ohm resistor. So between A and B we will get 1 ohm. 1 ohm is the effective resistance of the circuit shown. This, have you understood what is RT when 2 ohm resistors are R divided by N? That is, what is the value of R? R here equal to 2 ohm divided by number of resistors equal to 2. So we will get 1 ohm. So our this complicated network, a combination of network, this combination of network finally replaced with a equivalent network. So this is how we simplify the series parallel combination of resistors. We will see one more problem. Okay, this is another problem. This question we have to find the total. What is the total resistance of the circuit? That means between these 2 points, what is the total resistance? Okay, now these two 10 ohms are in parallel. What happens? When two 10 ohms are connected in parallel, what happens? Effective resistance will be RT equal to R divided by N. That is 10 ohm divided by 2 equal to 5 ohm will get. We will replace with the 5 ohm resistor. So then the simplified diagram will be like this: 5 ohm in series with another 5 ohm in parallel with 10 ohms. This was one of the ISR question. So these questions are not so complicated. It's easy. You have to just focus and simplify it. This is 10 ohm. Yes, given. What is the other resistor here? This is also 10 ohm. And here it is. What is the other resistor? One down, one resistor is there. This network, that is also 10 ohm resistor. So these 2 points we have to find what is the equivalent resistance. Now these again we can simplify this 5 ohm and 5 ohm in series. So again I will redraw this 10 ohm is there. One more 10 ohm. Again one more 10 ohms. This is 10 ohm. This is also 10 ohm. This is also 10 ohm. Oh, lot of 10 ohms. This 5 ohm and 5 ohm in series becomes 10 ohm in parallel. Now again, this 10 ohm and 10 ohm in parallel, what it gives? It gives 5 ohm. So this circuit can be replaced with 10 ohm. Again 5 ohm. I hope you understood how the 5 ohm has come. Already we have solved. So this, what will be the values? This will be 10 ohms, and this also will be 5 ohm. 5 ohm. This will be 10 ohm. So effectively, if you measure here, what is RT? RT equal to 3 resistors are in parallel. That is 10 plus 5 plus series. Sorry, these 3 are in series. 10. So what will value? 25 ohms. So this is the answer for this question. Option B is the answer, 25 ohm. So friends, I hope these videos are useful to you. Please share the videos with your friends. So next we will learn about Kirchhoff laws, that is KVL and KCL. So see you in the next lecture. Thanks for watching. See you.